Hello friends, welcome to my YouTube channel Spiral Learning. So today we are going to discuss the topic related to electric charges and field, which is the first chapter of Electrostatics of Class 12 CBSE from NCERT syllabus. So our first topic is dimension of permittivity of free space, then an application of Coulomb's law, then vectorial form of Coulomb's law. Let's start. So first of all, the dimension of permittivity, for the calculation of dimension of permittivity, we know, first of all, we should know the mathematical form of Coulomb's law, okay, which is discussed in the previous video. So let's start with the mathematical expression of Coulomb's law, which is the first topic, dimension of permittivity of free space. The mathematical expression of Coulomb's law is force F equal to 1 by 4 pi epsilon naught. Epsilon naught is the permittivity of free space. Q1 Q2 by R square, where Q1 and Q2 are 2 point charges kept in vacuum or free space, and R is the distance between the 2 point charges Q1 and Q2. Okay. Epsilon naught is the permittivity of free space. So we are interested to find out the dimension of epsilon naught. For doing this, we should modify this expression or simplify this expression. In this way, epsilon naught equal to 1 by 4 pi, then Q1 Q2 divided by F dot R square. Okay. Now we are going to put the dimension of each of the physical quantity. Here the physical quantities are charge, force, and this is distance or distance between the two charges. And this 4 pi has no unit, it's a dimensionless constant, so we are putting here 1. So what is the dimension of charge? We know charge Q equal to current I into T. I, the dimension of current is A and the dimension of time is T. So the dimension of charge is AT. Okay. So here two charges, that's why we are writing A square T square. And the dimension of force is well known to us. It's m l t to the power minus 2, and the dimension of distance is L. Here it's L square because it's R square. Okay. Now little modification. So m will goes there upward. So it becomes m to the power minus 1. Here is a 1 L and then L square. So it's become L to the power minus 3 when it go up, and then t to the power, this will go up plus 2, and there is also a 2, so it's 4, and then a to the power 2. So this is the final dimension of epsilon naught, that is permittivity of free space. So what is the dimension of permittivity of free space? Permittivity of free space means we can use it for every kinds of permittivity, not only in case of free space or vacuum. For any medium, the dimension of permittivity will be like this: m to the power minus 1, L to the power minus 3, t to the power 4, and a to the power 2. So this is the dimension of permittivity, which is very, very important for examination perspective. So many times it is asked in the CBSE examination. Okay. So now our task is to find out the application of Coulomb's law. So for doing this, we are considering an example. We are considering 2-point charges. Point charge, that is, the charges are very small in magnitude. Okay. So the charges are, we are considering 2 charges and they are separated very small distance. Okay. Let us consider the application of Coulomb's law. Application of Coulomb's law, that is, from Coulomb's law we can calculate the force between 2-point charges. Here we are doing the same one. We are considering 2-point charges and they are separated by a distance. By applying Coulomb's law, how can we find the value of this force? We are going to find out this force. Okay. So calculate the force between 2-point charges, 2 microcoulomb and 3 microcoulomb, and they are separated by a distance of 3 millimeter. Okay. So this is the situation. Under this situation, we are going to find out the Coulombian force when the 2 charges are 2 microcoulomb and 3 microcoulomb, and the separation between them is 3 millimeter. Okay. For the solution, first of all, we should write the mathematical expression of Coulomb's law, which is F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay. According to our question, Q1, suppose Q1 is 2 microcoulomb and Q2 is 3 microcoulomb, and the distance R is 3 millimeter. First of all, our task is to convert all this unit into SI unit, because we are going to convert all this unit in SI unit. Without converting the unit, we are not able to calculate the appropriate value of the force acting between the charges. So for the conversion of microcoulomb into coulomb, we will multiply it with 10 to the power minus 6. So 2 into 10 to the power minus 6 coulomb, then 3 into 10 to the power minus 6 coulomb, and then 3 millimeter, 3 into 10 to the power minus 3, then it will convert in meter. Okay, let's solve the problem. And here another thing, the unit of 1 by 4 epsilon naught is also known as, which is also explained in the previous video, 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. This is also the SI unit. Okay, so now we are going to put all the values in the mathematical form of Coulomb's law. So 9 into 10 to the power 9, Q1 is 2 into 10 to the power minus 6, Q2 is 3 into 10 to the power minus 6. So it becomes 10 to the power minus 12 at 3 to the 6. Here we will write 3 into 10 to the power minus 3 whole square. Okay. So now 9 into 10 to the power 9, then 3 to the 6, 10 to the power minus 12 is 3 3 is a 9, then 3 to the minus 6. 9 will cancel out, and after modification we will see that it's 6 into 10 to the power 9, then it's 10 to the power 12 minus 12, sorry, and while it will go up, it becomes positive 10 to the power 6. So it becomes 10 to the power minus 6. So 6 into 10 to the power 9, then 10 to the power minus 6. So the final result will be 6 into 10 to the power 3, that is 6,000 Newton. Okay, the force is quite big force, 6,000 Newton. It's not a small force. So without calculation it is very difficult to guess the amount of force. So after calculation we will get the result, and the force is a huge force which is 6,000 Newton, which is acting between 2 point charges. One is 2 Coulomb, another is 3 Coulomb, and the distance is very small between them, which is 3 millimeter. So this is the beauty of calculation, and that's why we will realize what is the impact of this law in our day-to-day life. Okay, so now the third content or third topic, which is vectorial form of Coulomb's law. Okay, again for vectorial form of Coulomb's law, we should know the mathematical form of Coulomb's law, which is very effective for all the topic that I also explained in the previous video. This is very important. Okay, so vectorial form is very easy, and since Coulombian force is a vector quantity, and we know it from very beginning of our course that force is a vector quantity. Okay, vectorial form. We know the mathematical form of Coulomb's law is F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, where it is necessary to write it here, where Q1 and Q2 are 2-point charges separated by a distance r in air, medium or vacuum, vacuum. Okay, fine. Or we can write free space. Free space. Free space. Free space. Okay. Fine. So that's all. So for converting this into a vectorial form, first of all we should know that here this is a force, it is a vector quantity in the left side. So in the right side, first of all we should analyze the quantities, then we will realize how to convert it into a vector. Okay, here charge is a scalar quantity, we cannot convert it into a vector. 1 by 4 pi epsilon naught, it is also a constant, it has a dimension, undoubtedly it has a unit also, but it is a scalar quantity. Here the distance between the two charges, if we consider this one as displacement, not as distance, so we know that in the suppose this is left hand side and this is right hand side, and in the right hand side there is only one quantity which has the property to convert into a vector, which is r. So first of all we should multiply it with an r cap. R cap is the unit vector, and the unit vector is a fantastic physical quantity, and unit vector can convert a scalar into a vector without disturbing its magnitude. Okay, so let's put it. So when we put a vector sign in the left hand side, then 1 by 4 pi epsilon naught, or you can write it as k q1 q2 r square, then there is a r cap. R cap is the unit vector, okay, which convert this total quantity into a vector without disturbing its magnitude, because the magnitude of r cap is equal to 1. So when we take the modulus in the both sides, so it becomes 1 and it will not disturb the magnitude. Again, by the definition of unit vector, by definition, r cap equal to the vector itself divided by its modulus. Okay, r cap, by definition we can write r cap, that is the unit vector is nothing but the vector itself divided by its modulus. So we can simplify it in this way: r vector divided by simply r. So if we put it here, the expression becomes 1 by 4 pi epsilon naught, then Q1 Q2 R square, then the vector R divided by its modulus. So if we multiply this two, then it becomes R cube. So F vector equal to 1 by 4 pi epsilon naught Q1 Q2 R cube and the vector R. So this is the final vectorial form of Coulomb's law. Okay, that is the final expression. So that's all for today. Thank you for watching the video. We'll next come with another video. Thank you.